more complex an application gets, the harder it is to actually develop the application or to develop new releases. And the reason is that even a small application change requires a complete rebuild, it requires a testing plan, it requires a full deployment, it requires all the lovely things that we love to do when we develop applications. And impact analysis on a failure is obviously a huge topic because it's a big application. It could be thousands, if not millions of lines of code in a single application, and it's really, really hard to troubleshoot. Right? I don't know, there's maybe some languages where it's easier than others, but if you look at a complex, let's say, Java application, troubleshooting can get quite difficult at times. And the biggest challenge is probably the one that you can have a frequent change and rebuild of the application. Because on the one hand side you have to fix things, on the other hand side you have to improve things. On the third side you have to bring new features into the application, and that makes frequent releases more difficult and more difficult and more difficult. And there's other challenges. And the other challenges are obviously that you are kind of committed to a technology stack. So if you started on a JBoss server, it's not something that you easily port to a Tomcat. If you started on, let's say, PHP-based architecture, it's probably not as easy to move that to Python or Ruby or whatever as the latest and greatest in web development. And typically a rewrite of the application means a complete rewrite. So it's not just you can't change tiny little bits of the application, but you typically have to completely rewrite it to make it work again. And ultimately, the whole module dependencies that you have in your application, especially if you use open source, some tools may not even exist anymore, right? Or they may be incompatible with newer versions of Java or newer versions of a certain compiler. So even a single module dependency could force a full rewrite of an application. Now, and the most important thing is one failure brings the whole application down. Right? It's that little semicolon that is missing sometimes, and it brings down the entire application. Right? It's this whenever the big guys say the error was missing a missing semicolon and missing colon. So very difficult to troubleshoot that. Now, the other biggest challenge, and I'll kind of show that in pictures, is the scaling piece. So what a lot of people do is they do horizontal scaling. They say, I have this one database, and I'll basically deploy the application multiple times. I may put something like a load balancer in to balance the load, but ultimately I'll use the same database, which could potentially become a bottleneck quite soon, especially when we're talking about big data and more data being generated, more data being consumed. The database becomes a critical bottleneck here. Now there's the vertical scaling approach. Is this phenomenal, I'll make the box bigger kind of thing, which is literally I put more memory in, I put more disks in, I put more CPUs in, and there's certain limits to that as well, and my database kind of grows with that. So that's kind of the vertical scaling approach. Now, the smart people, they would do something like that. They would do data scaling. So they would actually split the data and make something like a memcache in between and make it somehow look at a similar application. So it's really difficult to scale a monolithic style application. Right? There's only these ways you have, and it's really not something that works extremely reliable and extremely efficient. Now, how do we solve these challenges? And one way to solve them is microservices. And what microservices are, this is a single application, and all these different modules, the ordering module, the logistics module, the backend module, and the user interface module, they talk to each other, right, using APIs, but they can be scaled, operated, programmed completely separately. So this could be a Java application, this could be, I don't know, a Node.js application, this could be a PHP application, and user interface could be a Python application. And each of these things could have a different database, right? So it's fundamentally important. So it could be a relational database there, it could be a NoSQL database, and it could also be just a file system for storage. So it's critical. So all these things are separate. The only thing which is standard is they talk to each other using APIs. It's a completely different way of building applications. Initially, it's a much bigger effort, but over time, it gives you great ability because you can just change a module. You don't like this module anymore, you can literally just write this module new because you kind of know exactly what's going out and what's coming in. So it's kind of a very easy way to develop applications. The other thing is that you can actually scale your teams based on these different microservices within an application. So you might have a team that is bigger, that works on, let's say, the ordering pieces. You might have a team that works on the logistics pieces, and you might even have an external team, yeah, or a team in a different country that, for instance, works on the back-end pieces. Just making sure these bricks or these applications, these little services talk to each other to form one application. Now, to be very easy, what are the benefits? So the benefit is that actually the only thing we have to care about is that applications can talk to each other and that we have well-defined APIs to let them do that. There's now these API brokers, there's standard protocols that are evolving, so it's really easy, like REST, to exchange information between applications. And you can basically add modules based upon business requirements. Because as you've seen in the previous example, these applications, it could be one application, but they are modeled after business processes. There's an ordering process, there's a logistics process, and there's a certain back-end process. And if there's a new business process coming into play, you can literally just add the module and have it talk to all the other applications independently. So it's very nice to kind of construct an application around the business you are in. A prominent example of microservices is Netflix. So Netflix is probably the #1 user of microservices architecture. So whenever they embed a new service, they don't need to rewrite the whole thing. They just add a little snippet and connect it to the other application. So it's a big difference. You can change the modules independently, meaning that you can update one module. If that fails, you can roll back one module, but your whole application may still function, may still be able to work. If just the back-end piece fails, user interface is still accessible, and logistics and ordering still work, which is kind of what is critical for your business. And you can have different teams work on their own problems. I was in a situation where we had an application that was literally developed by 60 different people in 4 different countries. Guess what? It's not really easy to get them on the same page, to have them working on the same problem that covers the whole application. Having that independently makes it much easier to work on problems independently. And ultimately what you get is a faster time to market, and you still can integrate with SOAR. Because microservices define an application, they don't define the outer boundaries of an application. So if you have like a SOAR in place, you can still connect this microservice-based application to a SOAR-style infrastructure. And more importantly, and that's what I like, that you can scale everything independently. So one particular block or one particular piece in your application needs scaling, and you can scale it independently. And you can literally just hire developers for a particular piece. So they don't need to understand the whole application. They don't need to understand the whole modules in an application, the whole workflow. The only thing they have to care about is, let's say, their little piece, which kind of is a service within a big application. And there's many, many other benefits, right? There's also cons, obviously, because the initial investment, the initial kind of development time is much higher than in the traditional, let's say, LAMP-based application, where just go and start programming. You have to think about it a little bit more up front, but once you have that in place, it helps a lot scaling an application. Now, if we look at technology, which tools to use, some of the open source ecosystem tools, probably some tools you've never heard of before. One is obviously Docker, and I don't want to touch Docker in more detail, but Docker actually gives you the capability to bring an application into something which is a container, and a container is a unit that I can move from server to server, I can spin them up, I can manage them, so it's very easy to sort of virtualize an application. But the tools I want to talk about in the context of stream-based microservices are literally 2 things. It's something called Apache Kafka that we've heard of before, but I'll cover that. And it's a tool that I personally like because it's relatively new and it solves a relative challenge. It's Apache Myriad. Now, the challenge typically is, and this is a challenge when we interchange data between applications, it's the hard-working man in the middle challenge. Is this pipeline challenge, where you actually have to give data from one hand to the other. This is not a continuous flow. You have to wait for some service to finish, and then you can move data to the next service, to the next application. You have to wait until something finishes, and so on and so on. With streams and stream-based architectures, we are moving to a fluid model, where actually the data is in a constant flow, and it's always kind of transformed, and it's always worked on sort of on the fly. So as soon as data hits the system, it will follow the stream, and it will do its transformations, its aggregations, its interfaces with other systems on the fly. So it makes it a lot easier, because you don't have to wait until one service is finished to make that happen, to make that scale. Now, what we typically talk about there is the so-called message queuing systems. Perhaps a lot of the people who have developed, they work with message queuing systems. Prominent ones are probably RabbitMQ from the open source space. And RabbitMQ is all great, but what it doesn't do, it doesn't scale, first of all. And it's something that doesn't work on, let's say, a global scale. I mean, nowadays with clouds and everything is a service now. Your application components can be pretty much everywhere. You could have your web server running in Australia, your backend application running in the US, and maybe something is running in Italy as well, right? You never know. It depends on where sort of the cloud places your application. Now, to solve that challenge, LinkedIn initiated a product called Kafka. So it's a project that originated at LinkedIn. And it tried to solve the big data challenge in messaging systems. And what it is, it's basically a publish and subscribe system. So you think of that as an internet forum. So you have an interesting topic, and you can push a message to that topic. And if you're interested in what's in that topic, you can kind of subscribe to it and get all the messages that are being published to that topic. Now, what Kafka doesn't do, it doesn't allow for message persistence, so it's not something that is like a persistent layer, it's just a system to pass one message to a different system, literally. But it cannot persist them, and it doesn't do global applications. Which is kind of hard, because if you have, let's say, the modern style applications with modern businesses, which are pretty much everywhere across the world, I'll give you a good example, which is the gaming community. I don't know if you play online games, but they have one particular challenge. And the one challenge in online gaming is their game servers have to stay as close to the user as possible. So given that you have a player in Korea, and let's say you have a player in, let's say, Italy, it's probably unfair if the Italian player plays in the Korean game server. Given that latency is an issue, given that the Korean guy will see results faster. So they distribute these systems. Now the challenge is, how do they interact, these game servers, so that no one gets a benefit? That's especially important when you talk about real-time gaming. So you kind of get the concept. So game servers are everywhere across the world, but they need to have a consistent view on what's currently going on. And that's why Kafka is not a solution for them, because it cannot persist messages. Now, what we've done, and without talking too much in detail, so we kind of took the Kafka concept, put it into the file system, and make messages persistent availably on a global scale. So that basically means that pretty much everything on one hand side could talk to everything on the other hand side, and the data is always persistent at a certain point. Now, looking at that, let's say, from more like an architecture standpoint, so how would that, for instance, look like? And why is that Myriad an interesting one? Because I can scale my services on one particular platform. And that is really powerful. If you know what Apache Mesos is, it's a resource manager. It manages all the resources that exist in the data center, and it scale up and scale down, let's say, Docker containers. I'll give you an example. Let's assume I'm a game server, and now I have 50 million players. I obviously need more game servers than when I just have, let's say, 1,000 players. But I can scale that up and down, because there are certain peak times. People tend to play more in the evenings in Europe than in Korea, right? But what if I could use the same capacity to kind of spin up a Hadoop cluster at the same time? And this is what Myriad gives you. So Myriad is sort of the ability to dynamically add resources to Hadoop. So that means if you need less containers or less other workloads, Myriad has the ability to give that free resources to Hadoop clusters, which could then run for a limited number of time to produce certain jobs. Now, if we kind of combine that with the microservices architecture, all these things are in containers, all these things can scale independently, managed through Mesos. So literally what that means is you can scale pretty much on every level. You can scale Hadoop. You can bring up Hadoop if you need it, big data workloads like Drill. You can bring up Spark workloads whenever you need them. You can bring up multiple instances of these containerized applications, and you can scale them as dynamically as you could potentially want to scale them. And that gives you the great ability to kind of design global applications. Because once you have a persistent system that allows you to manage resources globally, you can have all these services distributed, and it doesn't matter where they are. And you really can kind of combine application components by these persisting streams based on, for instance, Kafka. Which is kind of nice because it gives you the ability to scale your application based on price as well. You could say, okay, my game servers are probably cheapest to run local to the player, but my user interface service, my backend service, is the cheapest if I run it in my data center. But I can decide whatever I want to do, and I can scale them all independently. And with that, it's just a brief introduction to microservices. It's kind of the end, and the only question is, and that's kind of a question I can't answer as well, is microservices or microservice architecture style the solution to all application development problems? Well, I don't know. The only thing we know for sure is that these monolithic style applications, they are probably dead. And you got questions?
Yeah, sorry. Which is the relationship between microservices and the OSGI?
Oh, okay. Yeah, it's that's a good question. That's a good question.
Not easy.
The OSGI is more at the application level. What you will try to do, when we talk about microservices this way, it's really different processes, entirely different processes, where OSGI is in one single application.
In a single JVM, yeah.
You want to load different library with different versions and control how it's loaded. And it's in the Java standard, it will become Java module one day if they want to do it. What we see is more really people having different process running in different contexts. So you will have one Tomcat where you may use OSGI to load some module here to do the user profile, and a Node.js application adjusting HBase database, and they are kind of totally different. It's kind of to work around these issues of having in a single VM too many stuff to load.
But still,
OSGI is needed for many applications.
Yeah.
But you can theoretically combine it. That's kind of why I stuck, because it kind of gives you the flexibility to use both if you want to, but there's no necessity to do it. Any other questions? I try to keep it as short as possible, because I know there's a strike upcoming or something.
Currently, networks, the key words are microservices, Docker, and DevOps.
Yes.
Okay. What about DevOps? The comparing to monolithic application and microservices?
Yeah, it's sort of really the separation of teams, because sometimes you application modules, you don't need, let's say, a highly skilled sort of application developer to do them, but maybe it's something like somebody hacks something together in Python and it does the job, which is sort of the DevOps model, right? Developers and operations come together, but it could be on an individual component. So you can have a very complex application development team for a certain module, and you can have these DevOps teams to sort of bring their application to market quickly. And that's why Docker becomes important, because Docker actually gives the ability to combine an application and the operational model literally into something they call container. Right? So I can kind of move the same things and I kind of use it at the same time. But the bigger challenge here is, and that's kind of the problem with Docker is great, but Docker, for instance, doesn't provide you persistency guarantees, because Docker is typically a stateless application. Now, if you want to have an application that stores data somewhere, you either have to use a database or you need to have a global file system that allows for these kind of operations. Questions?
So maybe, you know, you use Mesos and Myriad. Why that choice and not suppose using Yarn?
Yeah, so the thing is, the differences between Yarn and Mesos, and yeah, we kind of talked about that today. So the big difference is that Yarn is great for Hadoop workloads, but it doesn't do pretty much anything else. Right? So Yarn is great for Hadoop. Mesos is great for everything else but Hadoop. Yeah? To manage pretty much everything else, except for Hadoop. And Myriad is the bridge. So Myriad is the interchange between Yarn resources and Mesos resources. So that's why it's so incredibly powerful, because it gives you sort of the best of both worlds, really.
Just another question. I still have I'm waiting for attending the course of akka. Does akka helps on the developing microservice architecture with the reactor?
It does.
Does.
Yeah. But I think there's multiple approaches now. Akka being one of them.
One of them, yeah. But
I think
since
another
also
one that
Spark works under the rules, there's akka inside of it, so probably.
The big stuff behind akka and behind when you will move to microservices is really to have this eventing-oriented application. So you will have actors, in the case of akka, sending messages, but it's really having different services connecting, working asynchronously. And after you use akka or use anything else, it's okay. But for me, this is the mind shift you have to do. And the way you program from a very heavy monolithic synchronous way of working with having very, simpler until you have to modify one line of code that makes a full application. So you have reason why people are moving to microservices.
But there's, I mean, to answer that question in a different way, I think just last week I've seen, I don't know, 110 plus frameworks who could potentially be beneficial for developing microservices. The challenge would be to define which one is probably the one that becomes most prominent. I mean, Docker is sort of a de facto standard now, but there's other things like little container engines, so we'll see where it goes. But theoretically, so it's not a technology-bound shift. So it's, yes, you can use it, so you can solve it using different technologies that are out there, but it's more of a mindset shift.